So friends, in the earlier video, what we did is that we have solved the problems 1 to 6 of the SLM 1-1, right? So now we will be solving the other 4 problems in this video. So coming back to this, so in this problem, as you can see, it is given that x is equal to m plus a e. Okay, it is alpha t, it is actually supposed to be q, okay, plus b e minus beta k t. Okay, so now we need to find that how will the velocity behave. Okay, how will velocity behave with time t. So this is the ask in this question here. Now just to give you a context on how this works is that imagine that if x is equal to, if a function of x y is equal to a to the power x, okay, then dy dx is equal to a to the power x log of a to the base e. Okay, this is also called as a to the power x ln of a. Okay, so this is how it is defined as, right, dy dx. And if y is equal to, so I am writing as y1 so as not to confuse with the earlier one. If y1 is equal to e to the power x, then dy1 by dx is equal to e to the power x again log of the e. Okay, so now this part is equal to 1, so this is becomes ex. Okay, so dy1 by dx is equal to ex. So why I'm saying this, so as to give you context how does the exponential function differential work. Okay, so now coming back to this here, so let's come back to this problem here. Okay, so now x is equal to this, so dx by dt is equal to, now differential, now m is given to be a constant, so differential of any constant will be equal to 0. Now what about the differential of this? This will be alpha t cube into 3, this is 3 alpha, so we have to take the differential of this, right, because there is a t involved in this, so take a differential of this. So differential of alpha t cube is equal to 3 alpha t square, okay, into a e alpha t cube. Now what about the differential of this one? This will be, the differential of this will be minus beta k. It will be minus beta k into same thing, which is b e minus beta k t. Okay, so this is what the velocity is. So this is nothing but the velocity, as we discussed earlier. Velocity is given by dx by dt is equal to this. So in straight formula we can write 3 alpha t square a e alpha t cube minus beta k b e to the power minus beta k t. Now if you look at this, right, like if you let's look at these two components separately, if the value of t increases, then what will happen is that this is t cube here, right, so, and also there is a t square, so this will increase significantly. But what about this one? There's no t here. If the if this one, if t increases here, since this is e to the power, this, so this will not have much of impact, right? So this will impact will be very less. Okay, the impact of increase of t on x will be very less, right? So what will happen is that primarily when the value of t increases, the value of velocity will actually increase. Okay, so now it means that this will be the answer here. Okay, so why? Because as we mentioned, here, that velocity will increase with t. Okay, so that is the answer. The next one, a particle moves along straight lines with displacement at any point is given by s is equal to this one. Now what is the acceleration of the particle at t is equal to 2 seconds, right? So here I have been given s is equal to 4t4 plus 6t cube plus 9t square plus 14t plus 8. So if this is s, so what will be the velocity here? Velocity is equal to ds by dt, as we discussed earlier. This will be, what is the differential of this with respect to t? This is 16t cube. What is the differential of this with respect to t? It will be 6 3 18, 18t square. What will be the differential of this? This is 18t. What is the differential of this? This is 14. And this is a constant, so differential of this will be 0. Okay. What about the acceleration? Acceleration is equal to d2s by dt2. So this is equal to, again we have to differentiate this once again. So 16t cube, the differential of this is equal to 48t square. The differential of this with respect to t, it will be 36t, and the differential of this with respect to t, it will be 18. Okay. So now what is the question here? We need to find the acceleration of the particle at t is equal to 2 seconds. So what do we need to do here? We need to find the acceleration at t is equal to 2. So basically we need to find the value of d2s upon dt2 at t is equal to 2. So we just have to replace 2 here. So this becomes 48 into t is 2 square plus 36 into 2 plus 18, right? So this is equal to 192 plus 72 plus 18. This is equal to 282 acceleration meter per second square. Okay, so the answer will be this one. Fine. Let's go to the next one. A ball is thrown vertically with a velocity of, so imagine a ball is here, imagine a person is here, he's throwing the ball upwards, right? He's throwing the ball upwards. So what will happen is that at some point in time, it will become, the velocity becomes 0 and will start falling downward, right? So if this is the ground, it will come and hit the ground here once again, right? The same point. So now the ball is thrown with a velocity of 50. So u is equal to 50 meters per second. Okay. The velocity of the ball after 3 seconds will be this. Okay. So now, so what will be, so v is equal to u minus u plus at. We know that this is a formula. Here, since the body is going up, so acceleration due to gravity, since it is, the g is acting downwards, the velocity is upwards, right? The u is acting upward. So it means g is acting against the velocity. So this will be v is equal to u minus g into t. So initial velocity is given as 50 minus g is equal to 10 and t is given as 3. So this is equal to 50 minus 30. This is equal to 20 meters per second. So this is the value of velocity here. Okay. So the answer is this one. Let's go to the next one now. A bus traveling the first 1/3 distance. So imagine a bus is traveling. Okay, a bus is traveling from A to B. Okay, now let's split this into 3 1/3 distances. Okay, this is 1 by 3. This is 1 by 3s. This is 1 by 3s. Okay, so this entire thing is s. Then the entire thing from here to here is s. Okay, so the first half, the first 1/3, it is 15 meters per second. The second 1/3 is actually 30 kilometers per hour. Sorry. This is 15 kilometers per hour. This is 30 kilometers per hour. And this is 45 kilometers per hour. Okay. So we need to find that what is the average speed of the bus. So average speed of the bus is equal to total distance by total time. Okay. So now what is the time taken here, right? So if let's talk of this part, right? Let's talk of this part here. Okay. So the distance is 1 by 3s. 1 by 3s. And the time taken is equal to the distance is 1 by 3s divided by the speed, which is given as 15. This is equal to, so this is, for example, s by 3, s by 45. Okay. For the second half, for the first leg, so we are calling this as the first leg. This is the second leg, and this is the third leg. Okay. So the first leg, this time is this is what it is. The second leg time is equal to s by 3 divided by what is the speed here? In the second case, it is 30. So this is s by 90. And for the third leg means we're talking about this one. Third leg, the time is equal to s by 3 divided 45 kmph, right? This is equal to s by 135. So now what is the total time taken? Total time is equal to s by 45 plus s by 90 plus s by 135. Okay. If you take LCM, this is 270 6s plus 3s plus 2s. So 639, 9 to 11. So this is 11s by 270. Okay. Now imagine the average speed is equal to total distance is how much s, and time taken is 11s divided by 270. So h just gets cancelled. This is equal to average speed is equal to, I'm writing here, average speed is equal to 270 divided by 11. So 270 divided by 11. So the answer would be the first one. Okay. So this is the answer here. This is the last question in this. So I hope you were able to follow it, right? If you have any doubts, please reach out to us, and then we'll try to solve this problem. Thank you.